Hello again, everyone, and the last video we talked about inheritance relationships where there is a relationship. So we said something like a student is a person, a square is a rectangle, and we coded that a cylinder is a circle. And the way that we did that is we first made the circle class as the superclass and then made the cylinder as the subclass, and then we changed a few things about what the cylinder inherited from the circle, such as the get area, and then we added to it like a get volume. Today, or in this tutorial, I want to talk about compositional relationships. Compositional relationships is a has-a relationship. So anytime you can put the words has-a between two objects, you might be able to have a compositional relationship, like a classroom has a student or a list of students, a point, or I'm sorry, a circle has a point. Okay, and so that's one relationship that we're actually going to code today, and we can actually say lots of things has a point, like a quadrilateral has a series of points, 4 points to be specific, the vertices, whereas a circle has a center point. So let's get to this example. We'll code it out and see what happens. So the first thing we want to do is create a file called point. Okay. And in this file, I'm going to create a class called point. Okay. And if you can hear that dog, I apologize. So in my point class, I want to come up with a constructor, def init. Okay. And here I want to pass in two coordinates, an x and a y. Okay, so just a coordinate system. Now I'm also going to reintroduce the idea of a private instance variable. So I'm going to go self dot underscore underscore x equals x, and self dot underscore underscore y equals y. Now I just want to reintroduce this idea. It allows us to make sure that these attributes can't be manipulated from outside this class unless we go through things like set and get methods. So those are actually pretty simple to write. We can say def something like set x, and we can pass in a new x, and all we would say is something like self dot underscore underscore x equals x again. We can say def set y parentheses comma y, and we can say self dot underscore underscore y equals y, and what that gives us the ability to is change these from outside the class if we want to, but not directly, so we can't ever type underscore underscore x in a file or class outside of this one, but we can go through the set methods. And I should also write get methods, so def get x. Okay, now I'm not going to pass anything in there, so I'm just going to return self.x. Okay, and def get y, and I'm going to return self.y. Okay, and then maybe some object variables. For instance, a point, I should be able to calculate the distance from one point to another point. So maybe we do something like this. We'll go def distance to, and we'll say self, from self to the other point. Okay. And so a distance formula is basically Pythagorean theorem. It's going to be the square root of the difference between the x's squared and the y and the differences of the y squared. So we're going to sum those. So let's come up with a couple variables here, maybe a couple local variables. We'll go dx, the differences in the x's. So I'm going to say self.getx minus other point dot get x. Right. I can do my dy equals self dot get y minus other point dot get y. Okay, and then I can figure out my distance. So I could do something like this. I can say return, and we'll put this in parentheses. I'm going to go dx squared plus dy squared. And I want this whole thing square rooted, so I could import math in square root, use a square root function. So let's just do that real quick. We'll say import math. All right. And so down here, we're actually going to use this, and we're going to go math.sqrt, and what we'll do is square root the dx squared plus dy squared. Okay, so there's my distance 2, and I want to keep the class point pretty simple. There's probably some other things that I could do here if I really wanted to, but I want to keep it fairly simple. And so that's essentially what we have. If we wanted to test this real fast, we absolutely could. I can make another Python file called test. All right, and here I can go from point import star. And what I'll do is I'll create a couple points, maybe p1 equals a point, and we'll say that it's at like 3, 5. And we'll go p2 is a point, and we'll say it's at, let's go 6, 9. Okay. And really what I want to do is maybe just calculate the distance between these two. So let's just do a quick print, and we'll say p1 dot distance to p2. Okay, so that should print out the distance from P1 to P2. This is at 0.35, this is at 0.69, so the difference in the x's is 3, the difference in the y's is 4. So that actually makes a 3, 4, 5 triangle, so I should get that the distance between the two is 5.0 units. So it actually works perfectly. I know everything's working, so there's my point class. But really what we want to get to is a compositional relationship. So based on point here, I actually want to make another file, and I'm going to call it circle again. So I'm going to make a new kind of circle. And in the circle, it's going to rely on me passing a center point and a radius. So I need to import that point class. Okay. So let's create circle. Now this is not an inheritance relationship, so it's not an is, so I'm still going to type object here. Okay. A circle is not a point. It has a point. So we're going to go def init. And to make this circle, I need to pass it a point. We'll call it center, which is a point. And we're going to pass it a radius, which is an integer. Now remember, these are just kind of me typing what this parameter is going to be. So I'm saying a center is going to be a point, a radius is going to be an integer. It doesn't force it, but it says that it kind of should be. And so we'll make up our instance variables. So again, I can make them private here or public. We'll make them private if we want, or yeah, we'll make them private. So we'll go something like this. We'll go self dot underscore underscore center. We'll say is equal to center, and self dot underscore underscore radius is equal to radius. Okay. And then maybe in this circle class, we could do a lot of the same things we did before, like the area or the circumference. So we'll do something like def get area. Okay. And remember, the get area function is just pi times radius squared, so we can return, okay, pi, so we can go math.pi, actually, get a more precise value, times self.radius squared. Okay. We can do a get circumference. Okay. And remember, that's pi times diameter, so we'll return math.pi times radius times 2. Okay. And so essentially I have here a circle, and now I can build a circle in my test class if I really wanted to. So I could build circles around those 2 points. So I could say C1 is a circle. Oh, I would have to import it. With a radius of, say, 5. Okay. And then I could also print C1.getArea, and I would know the area of that circle. I think I hit the wrong button. Yep, well, it says the area of the circle, 78.5 units squared, whatever it may be. Okay, so there's this idea of composition where it's no longer just a matter of whether or not it is something, but it has something. So we built an object that has an attribute that is based on another object we may have created. So that's one way of going about it. And we can actually build all sorts of objects like this. It doesn't have to be just circle, but we could also create a class called quadrilateral, right? Which is another object. Okay. And in this class we might have something like a constructor, and this constructor may actually send it 4 points because it's a quadrilateral, of course, or a list of points. So we may even say p1 comma p2 comma p3 comma p4. Okay, and what I have here now is 4 points, and we could say that it's a list, and I could say self.points dot append p1, and I can essentially do that a little bit over and over and over again, and just change it from P1 to P2 and P3 and P4. And so now essentially I have this one attribute called points that has 4 different points in it. Okay, P1, P2, P3, P4, and I can do all sorts of stuff with it, like def, I could say get perimeter, right? And the perimeter is actually pretty simple. The perimeter of a quadrilateral is just the distance around it. So I can find a way to calculate that. So I can go distance, or I could say perimeter, so per equals, and I can say self.points at 0 dot, and what I can do anytime I have a point, if you recall, is I can get the distance to another point. So let's say self.points at 0 get distance to self.points at 1. So that'll be the distance from the first point to the second point, essentially. Okay, and then I could say per plus equals self.points at 1 get distance to self.points at 2, and we'll just keep doing this 2 more times. Perimeter plus equals self.points at 2 dot get distance of self.points at 3, and then we'll do per plus equals self.points at 3 dot get distance. And remember, there is no self.points at 4. Back to 0. So let's say P1 or self.points at 0 is the upper left to upper right. So left to right, upper right to bottom right to bottom left left to top left. So essentially I went around the whole thing. And all I would need to do now is return per. Okay, could I have done this differently, maybe in the essence of a loop or something like that? Of course, and I probably would have had we not been working with a quadrilateral, maybe something with more vertices, but a quadrilateral is simple enough just to add them all together. So here I've got my perimeter, and again I can come over here to the test and see if it all works. So I could come up with a few more points, say P2 or P3 equals a point at, say, I don't know, we'll go with 612, and P4 equals a point at 312. Right. And so now what I'll do is I'll make a quadrilateral. I'll call it Q1 equals a quadrilateral. Okay, I'm going to pass in the 4 points, P1 comma P2 comma P3 comma P4. I'll let it do its thing, and I'll simply print the perimeter. So we'll say Q1 dot get perimeter. All right, and it should be able to print that out for me pretty easily. No attribute called get distance. I must have spelled something wrong. Oh, it's not get distance, it's distance to. I am sorry. So let's just change these all to distance to. My mistake. Let's try running that one more time. And it looks like my test works just fine now. So remember, this was the distance from P1 to P2, so I know it worked. This was the area of the circle that I made based upon this point, the center point and the radius. And this is the distance around P1, P2, P3, P4 from 3, 5 to 6, 9 to 6, 12 to 3, 12. So I've got that nice little quadrilateral, whatever it may be, put together. But that's one way we can kind of use composition to our advantage here, where we can make something pretty simple, point, and then we can use that object in other things that are more complex, again hopefully with the idea of keeping them a little less complex because we already have that blueprint for a point and we can start using it in some of these other pieces. So hopefully that little tutorial helps get us on track. Again, if you have any questions, please feel free to let me know and I'd be happy to answer any of those questions as we go through, and we will talk to you in a little bit.